This requirement in the energy efficiency code specifies that for luminaires, which are light fixtures designed to use certain types of fluorescent lamps, specific types of ballasts, which are electrical components that regulate the flow of electricity to the lamps, must be used to improve energy efficiency. Using two-lamp tandem-wired ballast instead of single-lamp ballast reduces energy consumption because it ensures that both lamps in a luminaire are powered simultaneously. This eliminates the need for separate ballasts for each lamp, reducing energy losses associated with individual ballasts. Tandem-wired ballasts are more energy efficient than single-lamp ballasts because they share the same ballast and reduce the amount of copper wiring used. This reduces electrical resistance and improves overall system efficiency. Using two-lamp tandem-wired ballast allows for the use of smaller and lighter luminaires because the ballast is shared between two lamps, reducing the weight and size of the fixture. The requirement applies to luminaires designed for use with 1 or 3 linear fluorescent lamps, with each lamp exceeding 30 watts. The requirement applies when 2 or more luminaires are in the same space and are controlled by the same switch or control device. Electrical ballasts are a crucial component of fluorescent and high-intensity discharge lighting systems. The primary function is to regulate the voltage and current supplied to the lamp, ensuring stable and efficient operation. There are several types of ballasts, each with its own characteristics and applications. Firstly, there are magnetic ballasts. These are the oldest type of ballast and consist of a transformer and an inductor. They are relatively simple in design and are known for their reliability. However, they are also less energy efficient compared to electronic ballasts. Secondly, we have electronic ballasts. These ballasts use electronic components to regulate the voltage and current. They are more energy efficient than magnetic ballasts and offer features like dimming and instant start. Thirdly, there are hybrid ballasts, which combine the features of both magnetic and electronic ballasts. They offer a balance between cost and performance. Tandem wiring refers to a specific configuration where 2 or more lamps are connected to a single ballast. This is often done to reduce the number of ballasts required in a lighting system, which can save on installation and maintenance costs. However, tandem wiring also has its limitations. If one lamp fails, all the lamps connected to the same ballast will also go out. A ballast is an electrical component used to regulate the current and voltage supply to a lamp. It ensures that the lamp operates at its optimal level, preventing it from drawing excessive current, which could damage the lamp or cause it to fail prematurely. The choice of ballast depends on the type of lamp being used, the desired performance characteristics, and the application requirements. Different types of lamps, such as fluorescent, metal halide, and high-pressure sodium lamps, require different types of ballasts. For example, fluorescent lamps typically use either magnetic or electronic ballasts, while metal halide lamps require specialized metal halide ballasts. The energy efficiency of a ballast is an important consideration, especially in large-scale lighting installations. Energy-efficient ballasts can significantly reduce energy consumption and lower operating costs. Electronic ballasts are generally more energy efficient than magnetic ballasts. Some ballasts also offer dimming capabilities, allowing the light output to be adjusted to suit different needs. Dimming can further reduce energy consumption and extend the lifespan of the lamps. Ballasts are typically installed inside the light fixture or in a remote location. The installation must comply with all applicable electrical codes and safety standards. Regular maintenance is essential to ensure the proper functioning of ballasts. This includes checking for signs of damage or wear and replacing ballasts that are not working correctly. Proper disposal of old ballasts is also important, as some ballasts contain hazardous materials. The Energy Efficiency Code often mandates the use of specific types of ballasts to reduce energy consumption in buildings. These codes may specify minimum energy efficiency standards for ballasts and may also require the use of advanced ballast technologies like electronic ballasts and dimming ballasts. Understanding electrical ballasts is essential for anyone involved in the design, installation, or maintenance of lighting systems. By choosing the right type of ballast and ensuring its proper installation and maintenance, it is possible to optimize the performance, efficiency, and lifespan of a lighting system. Tandem wiring configurations, where multiple lamps are powered by a single ballast, offer potential benefits in terms of cost savings and simplified installation. However, it's crucial to consider the potential drawbacks and ensure that the wiring is done correctly to avoid safety hazards. The requirement for tandem wired ballasts is related to energy efficiency and aims to reduce energy consumption in lighting systems. The rationale behind this requirement involves several factors. One factor is reduced ballast losses. Using a single two-lamp tandem wired ballast instead of two individual single-lamp ballasts reduces the total number of ballasts in the system. Each ballast consumes some energy in the form of ballast losses, which are the energy losses associated with the operation of the ballast itself. By reducing the number of ballasts, the overall ballast losses in the system are reduced, resulting in energy savings. Another factor is improved system efficiency. Tandem-wired ballasts are designed to operate two lamps simultaneously, which can improve the overall efficiency of the lighting system. When two lamps are powered by a single ballast, the ballast can be optimized to provide the appropriate voltage and current to both lamps, resulting in more efficient energy conversion. This is in contrast to using two individual ballasts, where each ballast may not be as efficiently matched to the specific requirements of the lamp. Tandem wiring can reduce the amount of wiring required in a lighting system, which can also contribute to energy savings. By connecting two lamps to a single ballast, the number of wires needed to connect the lamps to the power source is reduced. This can reduce the electrical resistance in the wiring and minimize energy losses due to voltage drop. Tandem-wired ballasts can help to optimize the space within a luminaire. By using a single ballast to power two lamps, the size and weight of the luminaire can be reduced, which can be beneficial in applications where space is limited. This can also make the luminaire easier to install and maintain. The requirement for tandem-wired ballasts is intended to encourage the use of more energy-efficient lighting systems. By mandating the use of tandem-wired ballasts in certain applications, energy codes can help to reduce overall energy consumption in buildings and promote the adoption of energy-saving lighting technologies. The specific energy efficiency requirements for lighting systems can vary depending on the jurisdiction and the type of building. It's important to consult the applicable energy codes and standards to ensure compliance. These codes often specify minimum energy efficiency standards for lighting systems, as well as requirements for lighting controls, such as occupancy sensors and dimming systems. The Energy Efficiency Code aims to improve the overall energy performance of buildings and reduce their environmental impact. By incorporating energy-efficient lighting technologies, such as tandem-wired ballasts, into building designs, it is possible to significantly reduce energy consumption and lower operating costs. In addition to the specific requirements for tandem-wired ballasts, energy codes may also include other provisions related to lighting, such as requirements for lighting power density, lighting controls, and daylighting. Lighting power density refers to the amount of power that is allowed for lighting in a given area. Energy codes often specify maximum lighting power density values for different types of spaces, such as offices, retail stores, and warehouses. Lighting controls are devices that are used to control the operation of lighting systems, such as occupancy sensors, dimming systems, and time clocks. These controls can help to reduce energy consumption by turning off lights when they are not needed or by dimming them when daylight is available. Daylighting is the use of natural light to illuminate buildings. Energy codes often encourage the use of daylighting strategies such as skylights and windows to reduce the need for artificial lighting. Compliance with energy codes is typically enforced through building inspections and permits. Building inspectors will review the design and installation of lighting systems to ensure that they meet the requirements of the energy code. Failure to comply with the energy code can result in fines or other penalties. The Energy Efficiency Code plays a crucial role in promoting energy-efficient building practices. By incorporating energy-efficient lighting technologies and strategies into building designs, it is possible to significantly reduce energy consumption and lower operating costs. The use of tandem-wired ballasts is just one example of how energy codes can help to improve the energy performance of buildings. The Energy Efficiency Code promotes reduced energy consumption through the use of tandem wired ballasts. It also promotes improved system efficiency through the optimized operation of 2 lamps with a single ballast. The code also enables space optimization through the reduction in size and weight of luminaires. The Florida Building Code, Energy Conservation, often references ANSI/ASHRAE/IES Standard 90.1, which provides detailed requirements for building energy efficiency, including lighting systems. This standard specifies minimum energy efficiency standards for various lighting components, including ballasts. It also includes requirements for lighting controls such as occupancy sensors and dimming systems to further reduce energy consumption. The Florida Building Code also references the Illuminating Engineering Society IES Lighting Handbook, which provides comprehensive information on lighting design, application, and energy efficiency. This handbook includes recommendations for selecting and using energy-efficient lighting technologies, as well as guidelines for optimizing lighting levels and reducing glare. To comply with the Florida Building Code, building designers and contractors must ensure that lighting systems meet the minimum energy efficiency standards specified in ANSI/ASHRAE/IES Standard 90.1. This includes selecting energy-efficient ballasts, lamps, and luminaires, as well as incorporating lighting controls to reduce energy consumption. Building inspectors will verify compliance with the Florida Building Code during the building permit process and during on-site inspections. Failure to comply with the code can result in fines, delays in construction, and other penalties. The Florida Building Code plays a crucial role in promoting energy-efficient building practices in Florida. By incorporating energy-efficient lighting technologies and strategies into building designs, it is possible to significantly reduce energy consumption and lower operating costs, while also reducing the environmental impact of buildings. The use of tandem-wired ballast is just one example of how the Florida Building Code helps to improve the energy performance of buildings. The specific requirements for tandem-wired ballasts in the Florida Building Code may vary depending on the type of building and the lighting application. However, in general, the code requires the use of tandem-wired ballasts in applications where 2 or more luminaires are located in the same space and are controlled by the same switch or control device, as long as the luminaires are designed for use with 1 or 3 linear fluorescent lamps exceeding 30 watts each. This requirement is intended to encourage the use of more energy-efficient lighting systems and to reduce overall energy consumption in buildings. By using tandem-wired ballasts, it is possible to reduce the number of ballasts required in a lighting system, which can save on installation and maintenance costs. Additionally, tandem-wired ballast can improve the overall efficiency of the lighting system by reducing ballast losses and optimizing the voltage and current supplied to the lamps. The Florida Building Code also includes other provisions related to lighting, such as requirements for lighting power density, lighting controls, and daylighting. These provisions are designed to further reduce energy consumption and improve the energy performance of buildings. Compliance with the Florida Building Code is essential for building designers and contractors in Florida. By following the requirements of the code, it is possible to create energy-efficient buildings that are more comfortable, affordable, and environmentally friendly. The Energy Efficiency Code aims to reduce energy consumption in several ways. Firstly, it reduces ballast losses, as a single 2-lamp tandem-wired ballast consumes less energy than 2 individual single-lamp ballasts. Secondly, it improves system efficiency. Tandem-wired ballast optimize the voltage and current supplied to both lamps. Thirdly, it enables space optimization. Tandem-wired ballasts allow for smaller and lighter luminaires. Furthermore, it promotes energy-efficient lighting systems, encouraging the adoption of energy-saving lighting technologies. When referring to ANSI/ASHRAE/IES Standard 90.1, it is important to understand its scope and content. This standard provides detailed requirements for building energy efficiency, covering various aspects of building design and construction, including lighting systems. It specifies minimum energy efficiency standards for lighting components, such as ballasts, lamps, and luminaires. It also includes requirements for lighting controls, such as occupancy sensors and dimming systems, to further reduce energy consumption. The standard addresses lighting power density, which limits the amount of power allowed for lighting in a given area. It also covers daylighting, encouraging the use of natural light to reduce the need for artificial lighting. The ANSI/ASHRAE/IES Standard 90.1 is a comprehensive resource for building designers and contractors seeking to comply with energy codes and improve the energy performance of buildings. Understanding the requirements of this standard is essential for creating energy-efficient buildings that are comfortable, affordable, and environmentally friendly. The Illuminating Engineering Society IES Lighting Handbook is another valuable resource for lighting professionals. This handbook provides comprehensive information on lighting design, application, and energy efficiency. It includes recommendations for selecting and using energy-efficient lighting technologies, as well as guidelines for optimizing lighting levels and reducing glare. The IES Lighting Handbook covers various topics, including lighting fundamentals, light sources, luminaires, lighting controls, and lighting design methods. It also includes information on lighting for specific applications such as offices, retail stores, and industrial facilities. The IES Lighting Handbook is an essential reference for anyone involved in the design, installation, or maintenance of lighting systems. The Energy Efficiency Code is a set of regulations that aims to reduce energy consumption in buildings. The code sets minimum standards for the energy performance of various building systems, including lighting, heating, ventilation, and air conditioning. The Energy Efficiency Code is typically enforced by local or state governments. Building inspectors will review the design and construction of buildings to ensure that they comply with the requirements of the code. Failure to comply with the Energy Efficiency Code can result in fines, delays in construction, and other penalties. The Energy Efficiency Code is an important tool for reducing energy consumption and greenhouse gas emissions. By promoting energy-efficient building practices, the code helps to create buildings that are more comfortable, affordable, and environmentally friendly.